Alright guys, unfortunately today I have to be out to a training, but we're still going to have a lesson. Today's lesson is going to be 7.8, recursive functions and explicit functions. Our objective today is we will write recursive functions and explicit functions for arithmetic sequences. Now this is today's warm-up. I'm not going to go over this, and I'm not going to ask you to pause for time. You guys should have a handout that the sub gave you. Go ahead and fill that in. And the sub should have informed you, and Google Classroom should have notified you that this is due at the end of the period along with your homework. So I will be collecting both your notes and your homework. So go ahead and take some time to do this. You can pause the video if you like, or keep listening to it. Alright, so to recap, arithmetic sequence. A list of numbers with a constant difference between consecutive terms. Now we learned about this last week, but just want to review so that when you guys get into the recursive and explicit portion of the lesson, you guys will be okay. Constant difference means there's going to be either adding or subtracting. Now if you look at this list, I've already done some of the work for you, but just wanted to quickly explain. The constant difference here is plus 7 because you are adding 7 for each term. So every time you add 7, you get the next term. Now the second sequence, it looks to be decreasing, and that happens to be decreasing by 3, so the constant difference here is negative 3. Now, recursive functions, if you remember from last week, they have a recurring pattern, and basically you find the next number by using the previous term. These are pretty easy to write, but as we mentioned last week, this right here, not very useful. Every recursive function that you write is going to have this, and then you're going to be adding or subtracting something from it today, because today is just arithmetic, so it's going to be this. You're going to be adding or subtracting to it. Now the explicit also has a recurring pattern, just like the recursive. This is actually very useful because once you write the explicit function, you can find any term, and these can be a little more difficult to write, but the ones today hopefully won't be that intense. Now this is actually copied and pasted from a previous lesson. It was from last week, so I already have this written out for you guys. Just wanted to review. So in this example, at the beginning we had 0 dots, so that's f of 0. The first minute, f of 1, we had 5 dots, and then f of 2, 2 minutes, we had 9 dots. Now the pattern that we see here, just to reiterate, is we're going to be adding 4 every single time, as we have here. And basically, last week you guys were asked to predict, 13 dots, and then we kind of, made a function. That function may or may not be the same as the function we write today. But I wanted to write the recursive and explicit functions for that particular problem. And I'm going to apologize for the handwriting. Attacking that handwriting, it's going to be me using the mouse. I could type this, but I don't know, I just like writing. Now, from here to here, the difference is plus 4. From here to here, the difference is also plus 4. From here to here, the difference again also plus 4. So it's a recurring pattern. It's always from the previous term. Now, like I said earlier, your function for the recursive is always going to be f of x minus 1. And then we're going to have something to go with it. So I'm actually going to go ahead and write f of x plus 1 all of them. Well, I want you guys to do that. I'm going to copy this. Now if you go to the next example, this is always going to be here. And I'm only doing 3 examples with you guys today. The fourth one is supposed to be you trying it by yourself. And the last 3 are actually the first 3 problems in the homework. So you're going to have that for every single recursive function. Now for this first one, we have plus 4. That's our pattern. So basically what we're going to do is we're going to add 4. And that's basically it. So I'm going to go ahead and do all the recursive functions for the 3 problems that we're going to do together. And I'll do the explicit afterwards. So if I go to this example, again, recursive, you want to talk about the previous term. So from here, the difference is 8. It appears that we're adding. Same thing here. Same pattern. And same thing here. So again, these functions right here, pretty easy to write. Basically, whatever you have in this column is what's going to go here. So I have a plus 8. Alright, on to our last example. Alright, so on this one, a little different. Still arithmetic, still sequence, but this time the numbers are decreasing, so that tells me I'm subtracting. Now 25 minus 19, that's 6, so the difference here is 6. Alright, previous term, so here to here, also going to be subtracting 6, and then same thing here. And again, just like the previous two problems, this goes behind your f of x minus 1. Alright, so to recap before I start the explicit, find the difference between the term and the previous term. Write that down here, and then this pattern will always go with your f of x minus 1. I hope you guys remember that f of x minus 1 basically means the previous term. So for example, the previous term right here is 13. So if I plugged in f of 3, this becomes f of 2, which is 13. If I subtract 6 from that, I get 7. Let me actually go ahead and write that out. So again, f of 3 minus 1 minus 6. So again, 3 minus 1, we get f of 2 minus 6. Now we already know f of 2 is 13. If we plug in 13, we're going to get 13 minus 6, which we know is 7. And again, this is only useful if we actually have the previous term. If I wanted to find something like bigger, like f of 10, I would need to know f of 9 to be able to solve this. Okay, so let's work on explicit now. Alright, so for explicit, we have to find the difference between the term and the original value. So if I start here, my original is a 1. It follows the same pattern as this one. I have plus 4. Now when I go to the next term, I have to focus on the original. So the difference here is going to be a plus 8. And I go to my last term and do the same thing. So I have 13, I have 1. The difference there is that we're going to be adding, or the common difference, my apologies, is that we're actually adding by 12 on this one. Now, you won't have to do super difficult problems with arithmetic sequences because the numbers aren't that difficult to work with. With geometric, they tend to get a little more difficult, but with these, they're not going to be that bad. Now, to start this function off, what you should really do is start with the beginning. So at the very, very beginning, I have 1 dot. So that's what I'm going to write here, 1. Now, I know I'm going to be adding what it appears to be multiples of 4. So if I look at this right here, let's put a 0 here. That looks like 4 times 0. This looks like 4 times 1. This looks like 4 times 2. And this looks like 4 times 3. Now if you look over here, the numbers that we have in the parentheses match the inputs. So these should basically be matching what's over here, and it should also match the information that we have on the left side right here. So it appears that every single time we're adding a multiple of 4. I'm going to write 4 here, and then I'm going to put my variable next to the 4 because, again, we're doing multiples of 4, but we don't know which multiple. Sometimes that multiple happens to be 0, sometimes it's 4, sometimes it's 8, sometimes it's 12, and so on and so forth. So this is how you write the explicit function for this particular problem. Alright, and I'm going to do the same thing here, and remember, I'm talking about the difference from the original value. So right here, The first one will always match the one we have in our recursive column. Now this one, we have a plus 16, and from here we have a plus 24. Now the first number and basically the numbers over here should be a big hint as to what's happening. Now there is no difference here, it says a 0. So we know that they're multiples of 8. So they're multiples of 8, and it really, it just changes what you're multiplying by. So for this one, we're multiplying by 0. For this one, multiplying by 1. Multiplying by 2 here. Multiplying by 3. So just like the previous problem, start with, well, the beginning. We began with, our first value was 1. So we're going to have 1 plus, now we have, again, multiples of 8, but we don't know which multiple, so we're going to have 8x. That's going to be our function. Now, these are both following the same pattern, and the last one won't be any different. Alright, so right here, again, the first one's always going to match. The second one's going to be a little different because there's a bigger gap there, so we're going to have minus 12. And finally, we're going to have minus 18. Now, these are all multiples of 6. Again, remember the first one, there is no difference. Alright, so we have multiples of 6. Now, I'm going to try to speed this up a little more, so I'm going to clone this. Not quite what I was looking for, but let's go with it. Yeah, I don't think that's gonna work, so sorry guys. I'm gonna kill a little time there. I should have edited it out, but I'm not going to. Alright, multiples of 6. First one's gonna be 0. Again, it all matches back to over here for our inputs. And it'll be very similar to the last two problems. I want you to start with the beginning. We began with 25. And then slowly, our sequence was that we subtracted multiples of 6. And again, we don't know which multiple, so we're going to put an X there. Now, just to cap off the lesson, this one's a little easier to find, for the most part, because it's always this and then minus plus a number, in this case because it's arithmetic. But not very useful. This right here, sometimes more difficult to find. We're working with arithmetic, so they're not that difficult, hopefully, but with geometric, they can get pretty out of hand. And then sometimes if you have a sequence that's not arithmetic or geometric, but it's still a sequence, these can be a pain to find. Now I do have more slides. This is the one I want you guys to try next. And then over here I do have your guys' homework typed up. If you guys have issues with this, we can potentially go over it the next day, but that's it. Go ahead and finish the rest of it, and it is due at the end of the period. Please use your time wisely. Good luck, guys, and as always, may the force be with you.